Welcome to educate.com. In this video, we will learn about shapes of atomic orbitals. The orbital wave function or psi of an electron in an atom has no physical meaning. It is simply a mathematical function of the coordinates of the electron. However, for different orbitals, the plots of corresponding wave function as a function of r, which is the radius or the distance from the nucleus, are different. According to the German physicist Max Born, the square of the wave function, which is the psi square at a point, gives the probability density of the electron at that point. The variation of psi square as a function of r for 1s and 2s orbitals is shown here. Notice that the curves for 1s and 2s orbitals are different. It may be noted that for 1s orbital, the probability density is maximum at the nucleus and it decreases sharply as we move away from it. On the other hand, for 2s orbital, the probability density first decreases sharply to 0 and again starts increasing. After reaching a small maxima, it decreases again and approaches 0 as the value of r increases further. The region where this probability density function reduces to 0 is called nodal surfaces or simply nodes. In general, it has been found that ns orbital has n-1 nodes. That is, the number of nodes increases with increase of principal quantum number n. In other words, the number of nodes for 2s orbital is 1, 2 for 3s orbital, and so on. These probability density variations can be visualized in terms of charge cloud diagrams. In these diagrams, the density of the dots in a region represents electron probability density in that region. Boundary surface diagrams of constant probability density for different orbitals gives a fairly good representation of the shapes of the orbitals. In this representation, a boundary surface or contour surface is drawn in space for an orbital on which the value of the probability density psi square is constant. In principle, many such boundary surfaces may be possible. However, for a given orbital, only that boundary surface diagram of constant probability density is taken to be good representation of the shape of the orbital, which encloses a region or volume in which the probability of finding the electron is very high, say around 90%. One may ask, why do we not draw a boundary surface diagram which bounds a region in which the probability of finding the electron is, say, 100%? The answer to this question is that the probability density psi square has always some value, howsoever small it may be, at any finite distance from the nucleus. It is therefore not possible to draw a boundary surface diagram of a rigid size in which the probability of finding the electron is 100%. Boundary surface diagram for a s orbital is actually a sphere centered on the nucleus. In 2 dimensions, this sphere looks like a circle. It encloses a region in which the probability of finding the electron is about 90%. Thus, we see that 1s and 2s orbitals are spherical in shape. In reality, all the s orbitals are spherically symmetric. That is, the probability of finding the electron at a given distance is equal in all the directions. It is also observed that the size of the s orbital increases with increase in n. That is, the size of the 4s orbital is greater than that of 3s orbital, which is greater than that of 2s orbital, which is greater than that of 1s orbital. And the electron is located further away from the nucleus as the principal quantum number increases. In our next video, Shapes of Atomic Orbitals Part 2, we will learn in detail about the boundary surface diagrams of p and d orbitals. Thank you.